So earlier we mentioned definite integrals, and what we're talking about are integrals that are defined over a particular interval, okay? And basically what we're going to do is use all the rules and the strategies that we learned through sections E, F, and G to find the area under a curve within an interval. And we're going to use the definite integral and the fundamental theorem of calculus. Like I said, this is something that we talked about earlier in the fundamental theorem of calculus. Let's just review what this is saying, okay? Capital F of x is the antiderivative of f of x. F of x has to be continuous on the interval from a to b. Now, what does it mean to be continuous?
Has no holes or asymptotes.
No holes or asymptotes, okay? Has to be continuous. So if it's continuous on the interval where x is between a and b, then the definite integral of f on this interval is the integral from a to b. You put the lower number on the bottom, the higher number on the top, okay, of f of x dx, and that will equal the antiderivative evaluated at b minus antiderivative evaluated at a. Yes?
What if it had like a slant asymptote, right? So it was technically, you could make an unbroken line through it,
Mm-hmm.
so you could still technically get the area because there is overlap there, but the lines don't actually touch each other. Like, what if there was a slant asymptote there?
That would be okay. It would still be continuous. Continuous, we're talking about going like from left to right.
Okay.
And understand here that the function itself doesn't have to be continuous everywhere, as long as it's continuous over the interval that we're looking at.
So it's just, it's basically no vertical asymptotes between A and B, right?
Yeah, we could have, well, let me draw that a little better. Let's say we've got, this diagonal asymptote here, and we have a vertical asymptote here, okay? If we're doing the integral from a to b, and a is here and b is here, we're not going to be able to do that because it's not continuous over that interval. However, if a and b are there, we can do the absolute, or the integral, okay, because it's continuous over the interval. All right? Great question. So, we've done some of this by hand. What I want to actually look at today is taking a look at how to do some of this with the calculator. All right, and I'm going to look briefly at both the 84 and the Nspire. Does anyone in here have the Nspire? Okay, so it's actually a lot easier on the Nspire, as a lot of things are. So let's start with, we're going to do the integral from 2 to 5 of x times e to the x dx. Now notice here, guys, this one we can't do even by substitution. Okay? We have x times e to the x. You might say, well, we have e to a function, but the derivative of that function is just 1. It's not x. Alright, so we can't do this by substitution. We can't do this with any of the rules that we have. Okay, so we're going to have to use our tool to do it. Okay, so for the TI-84, first of all, hit the math key. Let me get this out of the way. Alright, so on the 84,
I have 83.
it works, it's the same for the 83 as well. Okay, so if you hit math, and then choice number 9 is fn int. Okay, now what that means is that's the function and you're getting the integral. Okay, now here's an example for this problem, and here is what this function takes. So you're going to hit enter, on fint, you're going to type in the function with the x, okay? So x times e to the x power, and close my parentheses, all right? So notice the first thing you input here is the function itself. Then you put a comma in, right above the 7. And then we're going to put an x because that tells us, that's like when you write the dx at the end of your integral. You're telling it what you're going to integrate with respect to. Well, here you're going to integrate with respect to x. Then, comma, 2 and 5, your lower bound and your upper bound for your interval. So 2 and 5, close your parentheses and hit enter. And you get 586.2358 and so on. Okay? If we're doing this to 4 significant figures, we would make it 586.3.
So basically you're saying that we can't do it by ourselves, we need the calculator's help?
Yes, for this one, we would.
Is it like for everyone on the planet or just us right now?
Well, I'll tell you, I can't think of a way off the top of my head to do that without the calculator. Other than using the rectangles or the trapezoids and a sum and a limit, which is a real pain. So people can approximate it that way, but
So that wouldn't be on the IB exam except if it's calculated?
yes.
But if we were to integrate it, wouldn't it be like 1/2 x to this x squared times e to the x?
No, because there's a product here. This is the product of two functions, x and e to the x. And there's no product rule for integrals. Okay, so that's the challenge here that we run into, okay? Now, let me show you another way, and this is not, in fact, this takes a little bit longer, but it does help you visualize it. And that is actually doing it with the graph. Where did my mouse go here? There we are. Okay, so if I hit y equals, and in my graph I punch in x times e to the x, okay, and I graph it. Now make sure that your interval is within your window. We're doing the interval from 2 to 5, so I'm going to hit zoom and make sure it's set at zoom standard because that'll be sure to include my interval. Okay, it doesn't have to be totally on the screen, but notice what we have here. If I go to second calc, alright, see number 7 there, the integral of f of x dx? By the way, there's the derivative. You can find the derivative at a point if it's on the calculator portion. Okay. Alright, so number 7. Okay, the lower limit, you can just type in. You can scroll over, you can just type in x equals 2 and x equals 5. And notice it'll actually show you the area, okay? Now, if you're using this on the IB exam, if you do anything like this, I've mentioned this before, if you do anything like this, they want to see a sketch, okay? So, and it doesn't have to be anything fancy. Alright, here's our function. Here's 2, and here's 5, you know, and just put in what you used, okay? Calc integral of f of x dx, and write down your answer, okay? A sketch to accompany it. Don't just write plugged into my calculator. and here's the answer. Okay, that's not gonna fly. But a little sketch like that you can write down, and that'll be sufficient to show your work. Okay. Now on the end spire, it's actually a little bit easier. And I'll show you the button where you can find it. But it's so easy, I'm not even gonna like take the time to use the overhead to do it. On the end spire, I will blow that up. You can see, you can actually just type it in, just the way you would write it.
That's how I did it.
Yeah, that's what mine looks like as well.
Oh, you have,
That's,
Yeah.
no. that
when
one
you
is-
do fint?
Yeah.
Yeah.
that's
FNN?
what mine looks like.
Okay, it depends what firmware upgrade you have, I guess, for the 84. Some of them have that,
Do not go to math,
okay,
and then number 9.
math number 9, yeah. For the end spire, however, this button right here next to the number 9, it's like a template button. And you'll see one in there that has the integral, and you can then just type it into the boxes. It's really